So we will discuss another problem on block diagram reduction. So here you can see the question, find the transfer function of the given system. So you can see the block diagram is given here. So as usual, the first step is to find whether any cascade block or parallel block available in the block diagram. So here you can see there is no direct cascade block or parallel block or feedback block. So we have to reduce this block diagram using the block diagram reduction rules. So the first step is to change this summing point after the block G2. So the first step is to change this summing point. You can see this summing point. You have to change this summing point after the block G2 using block diagram reduction rule. You have to apply the rule of changing the summing point after a block. So we have to move this summing point to here. After that, you have to interchange the summing point in order to find a loop here. So we can see how can we change the summing point from this point to after the block G2. So here you can see that after changing the summing point or moving the summing point after the block G2, there is a block in that path. A block G2 is added here, and also there is an interchange of summing point is take place. Why are we interchanging this summing point? We have interchanged the summing point. We can simply interchange the summing points if there is no pick of points or any other blocks are there. We can simply interchange two adjacent summing points. So here in this problem, the interchanging of summing point is necessary, because then only we will get a loop like this. You can see a loop here, a feedback loop here. So in order to reduce that feedback loop, we have to interchange that summing point. So the next step is to eliminate this feedback loop. You can see the feedback loop here. In this loop, G2 and H2, G2 of S and H2 of S are two adjacent cascaded block. So we can consider this as a single block with transfer function G2 of S into H2 of S. Since these two blocks are connected in cascade, we can consider it as a single block with transfer function G2 of S into H2 of S. And you can see here there is a feedback loop with negative feedback. Okay, the feedback is negative feedback because you can see a negative sign here in this summing point. So reduce this feedback loop using the equation G divided by 1 plus GH. So after reducing the feedback loop with the equation, we will get a block like this. So that block is, instead of G, here the forward path transfer function is G3 of S, and instead of H, the feedback path transfer function is G2 of S into H2 of S. So by applying the equation, we can get a block like this. Now if you see, we can see that there is this block and G4S block are adjacent, or they are cascaded. So we can simply cascade these blocks, and this path, that is the branch with H3 of S transfer function, you can see that it's again a feedback loop with negative feedback. So again the next step is to combine these two cascade block and eliminate the feedback loop. So we have to combine these two cascade loop and eliminate the feedback loop containing this, or containing the feedback loop feedback path transfer function H3 of S. So this again we can reduce this feedback loop by applying the same equation g divided by 1 plus gh. Instead of h, you can see here the feedback path transfer function is h3 of s, but the forward path transfer function, we can see the forward path transfer function as, since these two blocks are cascaded, the forward path transfer function will be g3 of s g4 of s divided by 1 plus g2 of s g3 of s h2 of s. So by applying the equation g divided by 1 plus gh, we can reduce this feedback loop. So this is the equation. This is the equation for finding the reduced block. Okay, so we can see here g3 of s or g3 into g4 is the forward path transfer function. We can see here g3 g4 divided by 1 plus g2 g3 h2, that is the forward path transfer function. So instead of g, you have to substitute this equation here, and 1 plus gh, instead of g we have to substitute equation, and instead of h, the feedback path transfer function here is h3. So on reducing this, we will get an equation like this, that is g3 g4 divided by 1 plus g2 g3 h2 plus g3 g4 h3. So we will get an equation like this. So we can replace the feedback loop, this feedback loop, we can replace this feedback loop by using a block with this transfer function. That is the next step. So if we replace that feedback loop with this transfer function, our block diagram will be reduced like this. Now you can see that these two blocks are again cascaded, and there is a feedback path with a transfer function h1 of s, and it is a negative feedback loop. So after combining the cascade block, these two blocks, our block diagram will be like this. Now again apply the negative feedback loop equation g divided by 1 plus gh. Then we will get the transfer function like this. So this is the final transfer function of the given system, C of s by R of s. Now in block diagram reduction, one problem you can approach in several methods. There may be many methods to approach a problem. So here I have taken to change this feedback loop after the forward path transfer function g2 of s. So I am changing here or moving the summing point after the block g2. That is a method to reduce this block diagram. But if you want, you can change this pick off point here. So that is another approach for reducing the block diagram. There will be or there may be several methods for a same problem, but the final answer should be same in both the methods. So the next method is, you can change this pick off point. You can see a pick off point here, right? This pick off point you can change to here after the block g4. That is another method. So we can change this pick off point after the block g4 by using block diagram reduction rule, or changing the pick off point after the block. Now if you change this pick off point after the block, then you will get this as a feedback loop. G3 G4 will be cascaded and H3 will be a feedback loop. This will get as a feedback loop. So that is another approach. So in both ways you can do a problem, but the final answer should be same. Okay, so now after doing this, in this method, that is after changing the moving the summing point after the block G2, that is one approach. You can do the same problem with another approach, like moving the pick off point or take off point after the block G4. That also you can do, and you can check whether you are getting the same answer. Okay, thank you.